Okay. Hi everyone. So, uh, let's see. Today is Wednesday. Okay. Wednesday, April 24th. So today you're gonna have homework about 10.4 and 12.7, and you also have a quiz 7. Okay. So don't forget to take the quiz. And I have already graded quiz 6. Let's take a look at quiz 6. Okay, so let's see here. Quiz 6, we have two problems. It's about the separable differential equation and the first order linear differential equation. The first one is the separable. So we first make it to the standard form. Standard form means your left hand side is dy dx. Your right hand side is the product of function of x and function of y. And then we want to move all the y to the left. By moving, we mean multiply or divide. In this case, we divided by y on both sides. And we multiply by dx on both sides, right? And then we integrate 1 over y. Integral is natural log of our absolute value of y. And then we plug in the initial condition. We get c is negative 1 over 7. So then you just rewrite your solution. And the problem says no need to solve for y explicitly. So you don't have to say y equals something. Just leave it like that. And then number 2 is the first order linear. We want to make it to the standard form. The standard form is you want your dy dx on the left, and you also want your y on the left hand side. But here you want to subtract y. You cannot divide it by y, okay? Because if you divide it by y, this guy divided by y is 1. But this guy divided by y, you have e to the 3x over y. So your y is still on the right hand side. We're not moving it. So here we subtract y on both sides. Then this is the standard form. We have the p is the coefficient of y on the left hand side. It also includes a sign. So in this case, it's negative 1. So our integrating factor is e to the integral of negative 1, which is e to the negative x. And then your formula, you use y multiplied by the integrating factor equals the integral. The integrating factor times q. But do you see here is the product? Do we have product rule? No, combine them. You see, if you have x powers, combine them. If you see exponential functions, combine them. Everybody say, combine them. Combine them. Yes. And now, after you combine, you get e to the 2x. So integral of that is e to the 2x over 2. Then we plug in the initial condition to find the c. And for the first order linear ODE, it's very easy to solve for y. Yeah, you both sides multiply by e to the x, and then we can solve for y. So I will ask you to solve for y for the first order linear differential equation. So far, so good, everybody? Okay, let's look at our mistakes. So here, yes, you see it's right. And then when you put it back here, you'll see 5 over 2. Yes. Be careful. And here, oh, do you see this is not the standard form? You must be careful about your setup. The first step, make it to the standard form. Everybody say standard form. Standard form. You want to move the y to the left hand side, and then your p is the coefficient of the y. So therefore, so then the p is e to the integrating factor is e to the negative x. And your right hand side, The cube should be only consist of x. You should not see y in the cube. Okay? So your right hand side is a function of x. So be careful with that. And then here, combine them. No product rule. If you want to use integration by part, yes, it's okay to do that. But then here, uv, do you see uv is e to the 3x times e to the minus x. So it's still e to the 2x. And you will see after the integration by part, you kind of have the same answer when you simplify them. So this is e to the 3x. And it's negative e to the 3x times e to the minus x. So it's negative e to the 2x. And then here, when you integrate that, you'll see this is the e to the 2x over 2. And this is something times e to the 2x. When you combine them, you get the same answer as here. Okay, so be careful. And also here, standard form. Move the y to the left. But here, when we move, we mean divide. So divided by y, and then dy, and multiplied by dx. So the dx is on the right-hand side. So the y is not here anymore. It's on the left-hand side. So we don't integrate the y here. No product rule. We cannot integrate this part and integrate this part and multiply them. No such story. Okay, so be careful. No product rule for integrals. And that's why the left-hand side we get natural log of absolute value of y. And here the mistake is when you plug in the initial condition, the y becomes 3. So that's why here it's 3. And we can solve for c. And after you solve for c, you plug it back to the solution, okay? And so you get y equals a function of x. And you don't get constant number. Okay, see? Here, y is not a constant. Okay, so be careful. And here, yeah, good. So this is good so far. And then you plug in the initial condition to find the number c. Okay. Oh, that's it. Any questions about the quiz 6? All good? Okay, so today you have quiz 7. Okay, let's see. So last time we were looking at 13.1 notes with answers. We kind of review our trick parts, right? So today we continue to review it. So the last time we talked about SOHCAHTOA, right, everybody? So sine is what? Opposite over hypotenuse. Cosine. Adjacent over hypotenuse. Toe. Opposite over adjacent. Yes, everybody? Do you still remember? And then cotangent is the reciprocal of tangent. You still have the chapter 13 concept map? Yes? So last time we talked about we can use the hexagon help us to memorize all the trait identities. Right? Remember this part? So this hexagon, this is the hexagon, and we have the way how we draw it is the way how we read the 6 trig functions. Right? Sine, cosine, tangent, cotangent, secant, cosecant. And then we have a diagonal, 3 diagonals. The product of the 2 ends equals the middle one. Therefore, sine times cosecant is 1. Secant times cosine is 1. And tangent times cotangent is also 1. Right, everybody? And there are 3 upside down triangles. And the sum of the upper 2 vertex square equals the bottom square. That's why you get those triangle formula. And let's see. Okay, so therefore, if we have a triangle like this, how do we compute all the 6 trig functions? Okay, sine is opposite over hypotenuse. So 36 over 85, right, everybody? And cosine, adjacent over hypotenuse. So write down the numbers. Tangent is opposite over adjacent, right? Cotangent, reciprocal of tangent. Secant, reciprocal of who? Cosine. Secant is reciprocal of cosine, right? Cosine. Look at the diagonal. Secant, reciprocal of cosine. Cosecant, reciprocal of sine. Okay, so that's why if you know the first 3 trig functions, you know the rest because the remaining just the reciprocal of those 3. Right, everybody? Okay, now let's continue. How do we solve triangle? Like this problem. First, we label all the vertices and the sides, and because the angle C is 90 degrees, right, everybody? So this session, I need your attention. I know you don't need to take notes. That's why let's go through it quickly, and then we can start the new session. If you don't understand at some step, let me know, okay? So here, we know B is 62 degrees. Then A is then 90 degrees minus 62 degrees. Because the sum of the 3 angles in a triangle is 180 degrees, right? So 180 minus this minus that is 28 degrees. Good, because we know B, side B, we want to find side A and side C. But look at this, we know the angle B. The angle B, the side B is the opposite to the angle B, right? And we want to know the side C. C is the hypotenuse. Okay, so opposite over hypotenuse is sine 62 degrees. So sine 62 degrees B over C. B is 10. How do you solve a C? Cross multiply, right? So C times that equals 10. So C is 10 over sine 62 degrees. And you get 11.326, which kind of makes sense because 11 is bigger than 10. Your hypotenuse is longer, is the longest side, right? And how do we know A? Okay, we have opposite and we have adjacent. That is the tangent, right? Opposite over adjacent. And then how do you solve for A? Cross multiply. A times tangent equals 10. Therefore, A is 10 over tangent, 62 degrees. Yes, everybody okay with that? Good. Okay, so this is also similar. Okay, then I will let you to read at home. And the fundamental identities, the reciprocal identities, and the Pythagorean identities, I already show you by the hexagon. Okay, this is how I teach my student to remember it. And then you also know tangent is sine over cosine, right? So therefore cotangent is the reciprocal of tangent, so cosine over sine. So all the 6 trig functions can be expressed in terms of sine and cosine, because you have this tangent in terms of sine cosine, cotangent in terms of sine cosine, and secant in terms of cosine, cosecant in terms of sine. So all the trig functions can be expressed in terms of sine and cosine. So you only need 2, okay? Sine, cosine, more important. And here we have the cofunction identities. You know, sine and cosine, they are cofunctions, right? So therefore, this is called complementary angles. If 2 angles add together is 90 degrees, we call them complementary angles. If two angles, we add them together and get 180 degrees, they're called, do you still remember? Supplementary angles. Exactly. Very good. And we also have the negative angle identity. Remember the trig graphs? What does sine look like? Everybody, let's move. Like wave, right? Like wave. The star at the origin. How about cosine? Star at the top, the one, right? It's the wave. Tangent. What does tangent look like? Like that, like x cubed. Like x cubed. And you have a lot of copy of x cubed. Cotangent? How you flip it? You have a lot of copies of to flip the x cubed, right? And how about secant? And secant is 1 over cosine, right? So how you flip the up and down, up and down. Okay. Let me see. Do I have the trig graphs here? Oh, no, I don't have the trig graphs here. But on my website, you can go to my applied trig class, and then you can look at the formula sheet blank. Okay, and this has all the things we need. Okay, so you know the sine, the cosine, the tangent, and the cotangent, and secant is 1 over cosine. So 1 over 1 is 1. The 1 over something goes to 0. It's infinity, right? That's why it becomes up, down, up, down. And cosecant is also up, down, but you flip the sign. Okay? So you look at the side and then flip it over. Okay, so this point, the highest point and lowest point, still remain the same, but then you're gonna flip it. Okay, so up, down, up, down. And let's see. Yes, so we have the trig graphs. Then how do we simplify the trig identities? Okay. Here, we have the sum of two fractions. When you see something like this, you want to combine them to a single fraction. Okay? So you look at the common denominator. Look at the common denominator, which is 1 plus cosine x and sine x. The first fraction, you're multiplying by sine x on top and bottom. Do you see the top becomes sine squared? And the second fraction, we multiply the top and bottom by 1 plus cosine x, right? And then, we distribute. We have sine squared plus cosine x plus cosine squared. And you know sine squared plus cosine squared equals 1. Therefore, 1 plus cosine x, they're the same. So we can cancel them. We get 1 over sine x, which is cosecant x. Okay, everybody? And then example 5, we want to verify if the identities are equal. So change everything in terms of sine and cosine. That's what we do. So cotangent is cosine over sine. When you square it, it becomes cosine squared over sine squared. Right, everybody? And then tangent, sine over cosine. But when you square it, it becomes sine squared over cosine squared. Right, everybody? And now let's see what happened. When we distribute, okay, let me see. Wow. Oh, something wrong with my notes. This is shifted. This should be here. Do you see when we take the common denominator? This is cosine squared plus, and then the top becomes sine squared plus cosine squared, which is 1. So therefore, this guy, I don't know why my note is shifted, but then cosine squared and cosine squared cancel. And this is 1. Therefore, we have 1 over sine squared, which is cosecant squared on the right-hand side. Okay, so verify the trig identities, express everything in terms of sine and cosine. And because we're more familiar with sine, cosine, sine squared plus cosine squared equals 1. Okay, everybody? So then you should be able to do your homework 13.1. But again, our exam, I won't ask you problems like this. This is like a review. What I will ask you in the final is about the derivative of trig function and the integral of trig functions, which is 13.2 and 13.3. Okay, everybody? Okay, so now let's go to 13.2. Derivative of trig functions. Okay, derivative. Do you still remember the derivative sheets I gave you at the beginning of the semester? Let me see. Derivative, oh, no, not here. Okay, so I'll go back to our course first. Okay, so derivative and antiderivatives. This sheet, okay? We have this side is the derivative, and this side is the antiderivative, right? And derivative of a constant is 0. Yeah, so integral of a 0 is a constant. Derivative of constant multiple, we can put the constant in front. Antiderivative, we can put the constant in front, right? And here, derivative of sum or difference is sum of difference of derivative. Integral of sum and difference is sum of difference of the integral. Do you still remember that? And now, Pareto rule and quotient rule, we have those for derivative. But do we have something like that in integral? No. Everybody, no Pareto rule, no quotient rule for integral. Okay? So make sure what are you doing? Derivative or antiderivative? Okay? So be careful and use this comparison. And what other formula we learned before? X to the n times x to the n minus 1. That's the derivative. And exponential function, you multiply by a in front. Yes, everybody? And b to the x. B to the x times ln(b). Derivative of natural log is 1 over x. Therefore, this is the antiderivatives. And then we learn chain rule for derivative, and then we also learn the U substitution for antiderivative. U substitution when you see a composite function. And we have Pareto rule, but we don't have Pareto rule for integral, but we have something called integration by parts. Integration by parts only works for two types of the functions. They are x to the power a e to the bx, or x to the power a times ln bx. We only learned those two types. Remember, everybody? That's the integration by parts. And now we have the trig function. Okay, so it really, our list grows. But how do we memorize these formula? I'm going to teach you a trick. Okay, the trick is, imagine there's a house and sine and cosine, they are couple. Okay, so sine and cosine live together. Therefore, derivative of sine is cosine. Okay, so we can say the wife of the sine is cosine. Okay, and there is another house. Well, tangent has two wives, secant. You know, some countries, the husband can have more than one wife. You can imagine that. So in this house, tangent has two wives, secant and secant. So who's the family member of tangent? Secant squared. So the derivative of tangent is secant squared. And who's the family member of secant? Secant tangent. Okay, everybody? So use this story to help you memorize the formula. Okay, So that's why the derivative of secant is secant tangent. So this two story can help us to memorize the top three formula. Everybody okay with that? How about the bottom three? The bottom three, remember, is negative co of whatever above. So look at me. I'm teaching you the pattern, how to memorize this formula. The formula won't be given in the exam. So I hope you can learn this pattern to be able to memorize them. Okay, so minus co. Do you see this guy? Minus co. You can think about cosine is sine. Is that okay, everybody? Sine, cosine, they're co-function. So that's why here, negative derivative of cosine is negative cosine is like negative sine. Okay? Look at this. Negative cosecant squared. Yeah, everybody? Negative cosecant squared. How about here? Negative cosecant cotangent. Now, do you see the pattern? Use the two halves to help you memorize the top three formula. Then the bottom three for the cofunction is negative co of whatever above. Okay, so this is a trick how to memorize those six trig derivatives. And we're not going to show why we derive these derivatives because we don't have enough time. So what we can do is just memorize this and then see how to use this to solve our problem. But if you're interested to see the proof, feel free to ask me. I'm happy to show you the proof. Okay? All right. So everybody, let's read with me. Derivative of sine is cosine. Everybody say, derivative of sine is cosine. Derivative of tangent is secant squared. Say it loud. Derivative of secant is secant tangent. Say louder. Derivative of cosine is negative sine. Derivative of cotangent is negative cosecant squared. Derivative of cosecant is negative cosecant cotangent. Okay, everybody? Okay, now let me close this and close this. Okay, so everybody close your eyes. What is the derivative of sine x? Cosine. Right? Sine and cosine live in the same family. What's the derivative of tangent? Secant squared, because tangent has two right. Yes, secant. What's the derivative of secant x? Secant tangent. Good. What's the derivative of cosine? Negative sine. Good. What's the derivative of cotangent?
Negative cosecant squared.
Yeah, negative cosecant squared. What's the derivative of cosecant?
Cosecant.
Negative cosecant cotangent. Okay, everybody? So practice the formula at home every day. Okay? And let's see. Okay, so we're ready to find the derivative of the following. And when you differentiate, look it from the outside to the inside. And look at this guy, the outside format. Something over something. What is that? Product? Something over something. Quotient. Yes. So we use quotient rule. So quotient rule. Let's write down quotient rule. Okay. So let's do one thing in one step. So don't jump step. It's very easy to make mistakes. So we have the top. Okay. Quotient rule is the top Prime? Yeah, everybody? What was quotient rule? Do you still remember? Yeah? Over v squared. Yes. So that's why we have u prime. So the top prime, v, which is e to the 2x plus 5 tangent x. And then what? Plus or minus? Minus u. So write down the u times v prime. So e to the 2x plus 5 tangent x prime. And over what? V squared. E to the 2x plus 5 tangent x squared. Right, everybody? Okay. And we continue. See, the first step, we just use the quotient rule. And then the second step, we look at each factor. For each factor has a prime, then we have to differentiate it. If the factor has no prime, we just copy it. So let's see. What is the derivative of secant x? Yeah, secant x tangent x. Is that okay, everybody? Derivative of secant is secant tangent. Derivative of 3x? 3. So that's the first factor. Okay, we differentiate. The second factor, do we need to do anything to it? Do we need to do anything to it? Can we cancel? No, so we just copy it down. Don't change it. Copy down. So e to the 2x plus 5 tangent x and minus secant x plus 3x. What is the derivative of e to the 2x? What's the derivative of e to the 2x? What is that? 1 over, oh, that is the natural log. So this is e to the 2x is 2 times e to the 2x. Okay, so 2 times e to the 2x plus, what's the derivative of 5 tangent x? Yeah, very good. 5 secant squared x. And denominator has no prime, so we just copy it. Don't change it. See? All the factors. You have no prime. Then we're done. Do not simplify. Don't multiply out. Just leave it like that. Is that okay, everybody? All right. How about you guys do part B? Everybody do part B. So, Will, do you want me to print out? Okay. Who does not have the chapter 13 concept map? Do you all have chapter 13 concept map? You're welcome. Oh, by the way, if you haven't filled the evaluation survey, could you help me to fill it out? And your comment is so important to me. So it's on Canvas and course evaluation. Wait. Uh, 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 okay, we made it. Okay, so our class response rate is 25%. So if our overall response rate is 90% or above, then everybody will get 0.5 extra credits. 80%, 0.4, 70%, 0.3, and 60%, 0.2, 50%, 0.1. Okay, yes. So thank you for helping me to fill out the survey. I'm so happy to be your instructor this semester. Yeah, we will have a class photo. I will see like which class more people come, and then we can take a class photo together. Mhm. Okay. All right. That's finished. Mhm. Remember Prada's room? Let's check our answer. Okay. So we have the first term is a product of two functions. So we need product rule, which is the 13x cubed prime times sine x plus the u times the v prime. And then derivative of cosine is what? Negative sine x, right? The derivative of 13x cubed is 39x squared. And then times sine x plus 13x cubed. Derivative of sine x is cosine. Yeah, sine and cosine are in a family. And tangent has two wives, secant. Mm-hmm. Okay, so then this is cosine and then plus 5 sine x. Okay, everybody? Mm-hmm. So part C. Okay, part C. This is a quotient, right? So we use quotient rule again. So quotient rule. U, right? The U prime V. So U is the top, the numerator. Prime times V. And then what? Plus or minus? Minus U, which is the top, V prime. V is the bottom. Prime. And then all over V squared. Each step, you just do one thing. Do not skip steps. It's very easy to make mistakes. Especially our problem is now getting more and more complicated. So then you gotta slow down and do it slowly. This step we use the quotient rule. U prime v minus uv prime over v squared. So far, so good, everybody? And now, okay, which factor has the prime? We have to differentiate it. See? What's the derivative of 4 sine x?
4 cosine.
Yes, 4 cosine x. And what's the derivative of 9 secant x? Yes. Family member of secant is secant tangent. Yes, everybody? The second factor, do we need to do anything to it? No, just copy down. It has no prime, so don't touch it. So just copy down. How about the next factor? Do we need to do anything to it? So we copy down 4 sine x minus 9 secant x. Okay, next one. This one we gotta be careful. Derivative of 5 is nothing. But then this guy is a product. Yeah, we have to do product. X and tangent x, we have to do product rule here. What's product rule? Yes. So u prime v plus u v prime. So here we're doing product rule. Yeah, we do quotient rule and then product rule, right? And then the denominator is, oh, I copied this down. Okay. So then, do you see like every step we just change something? Many of the things we just copy. The next step, all this just copy down. Okay, so copy again. We have 4 cosine x minus 9 secant x times tangent x. 5 plus x tangent x minus 4 sine x minus 9 secant x. Okay. Okay, what is x prime?
Wait, 1.
Yeah, 1. Good. 1 times tangent x. This is 1. 1 times tangent x is tangent x. What is the derivative of tangent x? Secant squared. So secant x squared. Then over 5 plus x. Tangent x squared. Are so good, everybody? Yes. So every step we just do one thing and slow down, be careful, enjoy your work. And you don't have to simplify your answer. Just leave it like that. Okay? After you make sure all the factors you don't have time anymore, then you can stop. Okay. Let's keep going. And part D. Ooh, something times something. What do you do? Product rule, right? So let's write down the product rule. So that's the U, right? Copy down the U. Oh, I copied down the wrong thing. Be careful. U prime, right, everybody? U prime V. And then plus or minus. Plus U. So we copy down the U. Times V prime. So write down the V and then prime. U prime V plus U V prime. Yes, even though the problem looks ugly, okay, we take a deep breath. Look at from the outside to the inside. The outside is like a product, so we use product rule. Okay, and the next step, which factor has the prime? We differentiate. Okay, what is the derivative of e to the 2x? Yes, 2e to the 2x. Right, everybody? Okay, what's the derivative of negative cosecant 5x? See, this is a chain rule. Right, everybody? This cosecant, u is the inner function 5x. What's the derivative of negative cosecant u? What's the derivative of cosecant x? Yes, cosecant and cotangent u and times u prime. Right, everybody? Therefore, all my negative and this negative cancel. So we have positive cosecant 5x, because my u is 5x, cotangent 5x, and the u, the 5x prime. Everybody? If you're familiar with that, you know what is 5x prime? Yeah, exactly. So if you're familiar with that, you can just put this guy times 5. Okay? And the next factor, we don't need to do anything to it. So we copy down. Right? The next factor, do we need to do anything to it? No. So we copy down. Okay, so let's wait until everybody get to this step. Everybody okay? Up to this step? Okay, so we're gonna differentiate this guy. So you see is a composite function, and u is the inner function. So this is the u. Okay, what is the derivative of cosine u? Yeah, very good. Negative sine u times u prime. So negative sine u. U is this long big thing. 3x squared plus ln x. But times u prime. Oh my goodness, I ran out of space. Do you still have enough space? Okay, good. So u prime 3x squared plus ln x prime. Everybody? Okay, so let's continue and copy it one more time. So 2e to the 2x, don't need to change anything. And then do you see here, this is the 5. Usually we like to move the constant multiple in front of the function. So let's move the 5 in front. Then we have 5 cosine x, cosecant 5x, cotangent 5x. And then next factor, don't change it. Copy that. Next factor, don't change it. Copy that. Okay, do you see this negative? Can we move the negative in front of the product? Yeah, so we change this to minus. So then this is sine 3x squared plus ln x. Okay. Derivative. What's the derivative of 3x squared? 6x. Woo, yes. What's the derivative of ln x? 1 over x. Okay, good. This problem. Yay! Okay, so today you have quiz. Don't forget to take the quiz. So we go over the quiz 7 mistake on Friday, and then you have exams on Monday. So I hope you can work on your homework about chapter 10 and 12.7 and ask me questions. And your practice exam, ask me questions. I have plenty of office hours. So you want to get perfect scores on your homework? Come to ask me. And practice is how to look at all the problems. Yes, we only have 2 weeks left. Okay, have a good day. Next class, printout session 13.3. Okay. Bye.